Oh my gosh. Um, so we're not quite ready for it, but mode, radians, graph. How about this function? Does it look like it might be periodic? I agree. That's an interesting comment. It looks like it's going to be periodic. It looks like it repeats itself, like it goes down, it comes up, it goes down. As a matter of fact, what does this look like? Maybe it could be describing the Ferris wheel?
Yeah.
Every second? Over time? Isn't this what we sort of said? Like, as a matter of fact, here, let me change it. If you start here at the bottom of the Ferris wheel at time 0, then you go up to the top, then you go back down, then you go down even further to the bottom, right? I guess maybe you should start. Oh, how should I do this? Hold on. I have a better idea. I can do this. What about this? I've got it now. This will be it. This will be the Ferris wheel. So how about this? Here you are. You start at the bottom. You go up. You get to the highest point, and then you come back down. And let's see. Elizabeth said it'd be hard to tell unless we looked at like maybe a bigger window. And even this might not be like big enough to convince you, but maybe it'll be a little bit bigger. Yeah, that looks like it's probably periodic. And it looks like you're going up and down and up and down. Just a guess. I don't know. All right.
We're going to trick us and
yes.
Something that looks like that and then like goes crazy.
Yes. No. Actually, I think part of the deal is when we talk about models, it's really helpful for us, for whoever's talking about the model, to give you an idea of what we're looking for. So, like we'd say, an exponential model, a linear model. These models, we might say a periodic, or we're going to get to the point where we're going to call them sinusoidal models. Sinusoidal models. And sinusoidal implies that it goes up and down and up and down and it repeats itself. As a matter of fact, let's, are you going to forget it on purpose? Like, are you going to go home and be like, I'm never going to remember sinusoidal. I'm never going to remember sinusoidal. Yeah. All right. So it actually it comes from the fact that we talk about the sine function with an e. Sinusoidal is sinusoidal. Okay. Sine is short for sine, which is a ratio. Sinusoidal describes something that has to do with a sine function. Okay? It describes a function that uses the ratio. Let me give you a few definitions, and then we'll go back to periodic functions. If you take a look at this function, this is a periodic function, there are several vocabulary words that I should introduce you to. This line right here is called the midline. Does that make sense why we might call it the midline? Tell me this. On our Ferris wheel, where it had a 50-foot diameter, if you start at the ground level, which is 0, right? What's the highest point you get to? 50 feet. What's the midline of this? Say it loud and proud. 25. The midline's exactly in the middle of your lowest and highest point for a periodic function. Do you want to ask a question about that? Is that okay? Okay. Sure. In addition to the midline, another thing that we talk about is the amplitude. And the amplitude is how high above or below the midline the function goes. Now we have a very interesting scenario with our Ferris wheel problem. Because we start at the ground and go 50 feet up, and our midline is exactly in the middle at 25, what's the amplitude? 25. It's sort of a coincidence. Do you see how it's sort of a little bit of a coincidence? I have a better, what if, let's do this. Our Ferris wheel, because we don't want to start at ground level, don't you usually have to walk up like a little platform to get to the bottom, what do they call them?
Stairs.
No, the cars? Are they just called cars? Carriages? Okay.
Wrong.
All right.
Gondolas.
Gondolas. Are they? That's what they are, right? No. No, they are. All right. So to get to the seats, you usually have to walk up. So let's take this same problem and let's move it up 5 feet off the ground so that you walk up steps. So if we now walk up 5 feet, tell me this. Still a 50-foot 50-foot diameter. Where's the midline now? Let's stop and think. Hold on. Think. Process. Where's the midline? Shh! Stop, think, process. Sam, you seem to be raising your hand, which is a good thing.
Would you move the midline up 5?
Is that okay? So, Rafi, what would you be moving it up to? 30? So is that right? The midline's now 30? Because you get on at the bottom. The bottom is how high up? 5. The top is now how high up? 55. What's between 5 and 55? 30. Question, comment.
Question/comment. Okay, so you get to your on the seat, but the Ferris wheel might be higher up. Like might be not like might go below the seat. Am I making sense?
You are. You're being a little too nitpicky for me right now. I'm just using like a big example to sort of describe it, but you're saying like here you're hanging below the Ferris wheel, and up here you're not sticking up outside, right? Yeah, I understand.
Yeah.
You're still below the Ferris
Yeah.
wheel. I understand what you're saying. Let's like loosen up our idea of what. Yeah, like let's not be so. Yeah. Thanks. Wait, no. I have a question for you.
All right.
Did the amplitude change by moving up 5 feet?
Yes. No.
Yes.
No. You're
If the
signing.
distance, if the midline changes, then the amplitude.
But your function is starting point 5 or 5 units up.
We didn't talk about this.
What's the amplitude? You did tell me what the amplitude was.
30.
No. You said the amplitude was 25.
Still.
And so now my question is, did the distance from the midline to the top change?
No. Yes, it's 20 now because if the midline is 30 and the top is 50.
If the top is
55, 25.
and 30, and what's the bottom? 5. What's the difference between 30 and 5? 25. The midline didn't change. As a matter of fact, sorry, I said that wrong. What did I want to say? The amplitude didn't change. As a matter of fact, taking the Ferris wheel and moving it up or down doesn't change how far above or below the midline you go. It just changes where the midline is. Okay, so the amplitude is the distance from the midline, and that's really just going to depend on how big the Ferris wheel is. And there's one more thing we talk about, and we call this the period. And that's how long it takes to complete one cycle. Now, I know it looks a little different on my graph here, but if we were doing the Ferris wheel problem, the period would be 60 seconds, because I said it took 60 seconds to go around one time. Is that okay?
That's really fast.
Probably. Like, that's probably like be a speed racer kind of thing. Yeah, so I agree that this is not a realistic Ferris wheel that stops to pick up new people. Like, we're like, let's just say you're on a bike tire. You're a little ant that's going around. And a mean math teacher spinning around. What? Sam.
So, This function is representing, in this case, like the way a circle is, right? So, are you taking it and like flipping?
No. These are actually not half circles. Okay, that is not true. Okay. Monty.
So what would make the amplitude change?
Okay, that's a great question. If I wanted to change the amplitude of the problem that we're talking about, what would have to change?
The height of the maximum height. Speed of the wheel.
How do you change the maximum? You're on to something. The speed. Look, the amplitude, just how high, like, does spinning the wheel faster make you go higher? No, right? It makes you go faster. So the period, the speed, that doesn't change. Changing one thing is going to make you go higher. Now, not higher like this, higher from the midline. Like if I do this, that doesn't make me go any higher from the midline. If I do this, it doesn't make me.
You have to like make the Ferris wheel bigger.
Stretch it. Make the Ferris wheel bigger. I need a bigger Ferris wheel. So if the diameter of the Ferris wheel now is, instead of 50 feet, 60 feet, now my amplitude is 30. It's going to be half of that diameter. Okay? So changing the size of the Ferris wheel is going to change the amplitude. Changing how high up I place the Ferris wheel changes the midline, and changing how fast you go around will change the period. Okay? So those are sort of the concrete things. And they're new. It's new vocabulary. It's going to take us a while to feel good and comfortable and confident. Part of the homework is getting you to feel good and comfortable and confident. Reading the textbook's going to help you feel good and comfortable and confident. But you have to do all those things. And the more we say it, the better we're going to get with it. Okay? But they're new words. Danny.
How do you, if you ask a question like, what is the period, do you just write, like, if it's on a graph and you don't have a unit, like, how do you write that?
All right, so I actually need to see some sort of units to find the period in this case. So here I'd say, was that 1, 2, 3, 4, 5, 6, and a little bit. So this is like 6.28 is the period. Okay. You could actually do like Calc 0 to find the distance. That's what we're trying to do, find the distance between this. Interestingly, you could also find the period by looking at the distance between the tops. Right? You want to see something cautious though? Be careful. You can't look at the distance between the midlines. Because once you're going up and the other one you're going back down. If you want to use the midline, you have to go to where do you repeat yourself. Here I'm going up, here I'm going up. So this is also the period. Do you see how that could lead to confusion? The period is where you repeat yourself. This point and this point are not where we're repeating. One we're going up, one we're going down. And students mess that up. It's a hard one. Evan.
So would you change the problem completely with different periods?
If you sped it up?
No, I'm saying we got like the fixed periods of when like y was 0.
Mm-hmm.
And then we also did the period when y was like 0.
Yep.
Wouldn't that like change the problem completely? Like you would like have to solve something?
No, actually the whole idea of a periodic function is it's not going to matter if the problem stays the same. It's not going to matter where you look. The distance between where it repeats itself is always going to be the same. So it's not going to change it completely. It's actually going to be a constant, which is sort of nice. That's what makes it periodic. Let's see. I was hoping to get to a few. I don't know if that's going to happen. But, all right, let's take a look at maybe 1. And we'll talk about the period, the amplitude, and the midline. What's the period for the first one, 1a? Monty, you want to take a shot at the period? So every 2, this function repeats itself. And you can either look at the tops or the bottoms or the middles, but yeah, that's definitely true. Amplitude. Travis, you want to try the amplitude?
0.5.
Awesome. Very good. I should have asked you for the wrong answer. Let me try this again. What's the wrong answer for the amplitude? Not you, Travis. 1. Yeah, okay, yeah, that's wrong too. But the wrong answer is 1. Can you see why a pre-calc student might want to say 1? Yeah. Right? They're like, oh yeah, this is the amplitude. But Travis says no, the amplitude is how high up from the midline. And in this case, the midline is right here. And so the amplitude is how high up from that, and you get 1/2. Coincidentally, what's the midline? Y equals 1/2. Let's just do the midline for the next one. Let's do the midline and amplitude here. What's the midline for the next problem? Where's that line? Is that at 1 or 1/2?
1.5.
So is it 1 or 1/2?
0.5. No, it's
1.5. So if I need there, I'd have to be 1.5 at 0.5.
away from both those.
Yeah. What is? Can you tell me what the amplitude is if the midline's 0.5?
1.5.
The amplitude is 1.5. That's how high up it goes above and below 0.5. All right. Very nice work today. It's going to be hard, but we'll keep at it, and we're going to get more and more practice. What? I don't think we have assembly.
No, but we have another.
All right. Have a great day. Homework 6-1 from the syllabus. Do your work. Stay out of trouble. Be good and kind.